patient should be seated quietly for at least 5 minutes in a chair with a back support. Measuring supine and standing value may be indicated under special circumstances. Wrap cuff firmly around upper arm at heart level. The appropriate cuff size must be used to ensure accurate measurement. The bladder within the cuff should encircle at least 80% of the upper arm. Place stethoscope bell below the intercubital space over the brachial artery. Quickly inflate cuff pressure to 20 mmHg above cuff cough sound. Slowly relieve pressure at rate equal to 2 to 5 mmHg per second. Systolic blood pressure is the point at which the first of two or more cough sound is heard, and diastolic blood pressure is the point before the disappearance of cough sound. At least 2 measurements should be made minimum of 1 minute apart. Provide to patient verbally and in writing their specific blood pressure number and blood pressure goal. Indication for terminating exercise testing divide by 2. Absolute indication and relative indication. Absolute indication is a drop in systolic blood pressure of more equal to 10 mmHg with an increase in work rate. Then moderately severe angina. Next, increasing nervous system symptoms such as dizziness or near syncope. Next is sign of poor perfusion or subject desire to stop. For relative indication, so same as the absolute, drop in systolic blood pressure of more to 10 mmHg, and then the symptom of fatigue, shortness of breath, wheezing, leg cramp or claudication, and then increasing chest pain. Next is hypertensive response, blood pressure over 250 mmHg or systolic blood pressure more than 115 mmHg. Between the absolute and relative indication, which one from those two allow you to immediately stop testing is, I think, the absolute, because as you can see from this criteria is more to absolute than relative. First is onset of angina or angina problem, and then significant drop systolic blood pressure more 10 mmHg, and then the fatigue, shortness of breath, and signs of poor perfusion, and increased nervous system symptom, and fatigue, and lastly when the patient requests to stop. They can immediately stop testing because absolute indication can give them life-threatening or can harm them. So next we move to the component of HRF testing, which is the heart-related fitness. It has 5 components. First is cardiorespiratory fitness, muscular strength, muscular endurance, body composition, and flexibility. Under the cardiorespiratory test, it has a field test, cycle ergometry test, treadmill test, and step test. This test for examine the volume of oxygen and the heart rate. So if you if you are active person, you have a good result and low heart rate. The muscular strength test for determine the 1 RM or any multiple RM within 4 trials with rest period of 3 to 5 minutes between trials. The final weight lifted successfully is recorded as the absolute 1 RM or multiple RM. 1 RM refer to repetition maximum. Muscular endurance is the ability of a muscle group to execute repeated contraction over a period of time sufficient to cause muscular fatigue. Example of the test is a curl-up, crunch test, or maximum number of push-ups. The test for body composition divided by 2 anthropometric methods. Under the anthropometric method, it have a body mass index, circumference, skin fold measurement, and then the densitometry include the hydrodensitometry, underwater weighing, and plethysmography. Other technique we can test by dual energy X-ray exothermometry, total body electrical conductivity, bioelectrical impedance analysis, and near infrared intercadency. The last component is flexibility. Flexibility is the ability to move a joint through its complete range of motion. Flexibility depends on a number of specific variables, including distensibility of the joint capsule, adequate warm-up, and muscle viscosity. Someone who have a high flexibility usually can prevent from injury because of the higher level of range of motion ROM. Estimation of maximum oxygen consumption. The example of YMCA cycle ergometer test.
Now let's start the test. Have the client jump on the bike and get them to start pedaling at 50 RPMs. At the same time, set the ergometer workload to 0.5 kilopons and then press the start button on the stopwatch. Have the client pedal for 3 minutes and record the heart rate during the last 15 seconds of minute 1, of minute 2, and of minute 3. Now, if steady state heart rate was achieved, that means less than 5 beats per minute variance between heart rate 2 and heart rate 3, then use the average to determine the client's second workload. Note that if steady state heart rate was not achieved, then extend the test minute by minute until it is. In this case, their heart rate put them in the 2 kilopon category. So increase the workload to 2 kilopons, restart the stopwatch, and have them pedal for another 3 minutes. This time only take their heart rate in the last 15 seconds of minute 2 and of minute 3. Now keep increasing the workload every 3 minutes until the client reaches their heart rate cutoff. When they do reach this cutoff, it's important to remember that they must finish the last workload completely in order for it to count. Now use the final 2 heart rates from the last workload to determine SM2, and then use the final 2 heart rates from the second last workload to determine SM1. Input those numbers into Formula 2, and then use Formula 3.
So there is 4 categories on which the range of heart rate, and after we do a test, we take a last reading heart rate, and then we decided which is the category that a person is. So if someone have a physical fitness, if someone have a good physical fitness, or they are an athlete, so the heart rate will low, and it means that the level of fitness is high. But when the person is the sedentary person, so the heart rate will more than 99. So the level of fitness is low or moderate. Neuromuscular control is efferent motor response to sensory information. It means how our body respond or react after receive information. Under the muscular control, it has two types: kinesthesia and proprioception. Kinesthesia is the motion, awareness of body position and movement. Proprioception is a static. It is subconscious information used in the feedback control of posture and precise movement. This is the example of proprioception. As you can see, the figure show that the wolf is static standing, and while the eyes is closed, and it say that my foot is in front of my knee. The other example is when you standing on the grass while close your eyes. You can aware, or you can know something without looking at it. And then the kinesthesia is the motion. So the figure show that the wolf is close the eyes, and it say that I'm walking forward. So the body can perform a motion or can move without looking at it. Here is the difference between open and closed kinetic chains. Open kinetic chains is exercise that use of a combination of successively arranged joints, which terminal joint is free to move. And then the closed kinetic chains is the exercise which the terminal joint meet considerable resistance that prohibit or restrain free ROM, as a distal joint is stationary. So this is the demonstration on how to do a leg extension for open kinetic. For the closed kinetic, I choose a push-up exercise. So that's all for me. Thank you for watching.